Okay, so our product is the walk and grab cane, and it is basically a walking cane that has a grabbing feature. And this is by Kaylee, Paige, and Ramon.
So our presentation will have our introduction, design and manufacturing process, our challenges and problem solving, the device demonstration, innovation, key learning, and our future improvements.
So this is Meet the Team. I'm Kaylee, I'm our team lead. My job was to keep us on schedule and organized, and print out our parts throughout the manufacturing process.
Hi, I'm Paige. I was the design lead, and my role was uh, to create all the different designs for the product and choose which one best like worked with our goals, and then like create the handle and stuff with CAD.
I'm Ramon. I was the manufacturing lead, and my job was to choose materials that were best for our cane, and creating the upper shaft in CAD.
Okay, our introduction statement. So, our product consists of a functional walking cane. The main goal of the cane is for it to be cheap but durable, and also to be accessible for those who have hard time finding a cane that fits them properly. The cane will be able to adjust its height so that they can change it like over the day if they want to like wear different shoes or if like the terrain changes. And then um they'll still be comfortable walking it with it. And then lastly, the cane will be strong enough to uphold terrain changes such as rocks, grass, sand, and like more. Our main goals are that our main goals are that the cane must be durable and easy to manage, easily adjustable based on height, easy to store, and should be able to withstand different terrains and obstacles. And it should be able to pick up objects without the user having to like bend down, because if they have a bad back and that's the reason they have a cane, it would be bad for them to like bend down and pick up objects.
So this is our video demonstrating our cane. Uh, so we're picking up different objects of different sizes and materials. As you can see, that's yarn. Um, and this is just one of our handle examples.
Yeah, and so you can see the cane works well to pick up all different objects. And the next one, it's a bit harder for it because it is a full pencil case, but once you get the hang of it, it could print. Oh wait, that's an eraser. But if you get the hang of it, you can pick up a bunch of different objects like water bottles, full pencil cases, lanyards, and even at the end there, it's actually picking up a pair of scissors once you get past. There's a bit of a learning curve to it too.
But as you can see with the curved claws, it's able to scoop underneath objects to basically pick
Yeah.
up anything.
Like you can get in the handle of the scissors and you
Yeah.
can easily pick up a pair of scissors.
Here we've shown that there's two different types of handles that you can add to the cane as well, and then here we have a video of just walking with it to show the stability
And
of the cane.
that is just our overall cane with the different handles. And the black like tube in the center is the different like sizes that you can like actually take off one and then add another size.
So our project roadmap, basically was just like the steps we took to get to our final product of our cane. So step one was obviously deciding what we wanted to make, and it didn't have to be like a mobility device. There was a bunch of other options that you could have took, but we chose to make a adaptive mobility device. We had to decide what problem we wanted to solve. At first, it was just the like adaptive height, like to go up and down. Um, but then we realized like that wasn't enough to submit, so we did some more thinking and came up with the walk as the basis, the grabber as well. And then after we settled on that design, it was to basically design it in CAD, SolidWorks, and drawings as well. And then after we made sure all the sizes were correct, step four was to start the manufacturing process of 3D printing and putting stuff together. And then we had our final goal of our walking cane. Do you want to show it?
Yeah, yeah. Really can. It works very well. Okay, next were our design objectives. We had four main design objectives, which were functionality, strength, aesthetics, and then overall design. For functionality, when designing our cane, we wanted to make sure that it could actually be used. Like it had like correct sizes so that people weren't like completely like bending over like completely, and it was simple to use. And then we also wanted to add some moving parts, which is where the grabber part comes in hand. And then for strength, um, for the cane to be able to be usable, it needed to be strong enough to actually support a person. So because of that, we had to consider the types of material, the amount of parts, and the design of parts. For the strength, for the handle, we actually had to go through a bunch of different materials so that it didn't like wobble when they were holding it. And we tried with another material that actually like snapped. It was, what did we try it with? PLA
It
or
was just
something?
regular PLA,
Yeah.
yeah.
With PLA, the handle would actually snap, so we couldn't use that. And then for the third one, aesthetics, it had to be functional in strength and extremely important, but looks are also like very important, and you want to people actually want to like the cane they're using. They don't want it to be like ugly to look at or something. And then the overall design, key components to focus on were once again like strength, the weight, because you didn't want it to be like super heavy, the compactability, and the durability, because you didn't want their cane to break after like a week and then have to repurchase a new one.
So this is us modeling our design in CAD. The first image is our overall design. The second is the exploded view where you can see the different parts of the shaft and the handle and the three different grabbers, as well as the base. And then you see the drawing where we have all of our dimensions and everything and listed
Like the individual
materials.
parts,
Yeah.
but just like it put together, bill of materials, yeah. So our manufacturing objectives, this goes along with our timeline, the trials, prototypes, and then our overall final print. For the timeline, we wanted from final design to manufacturing, we wanted it to be about 2 weeks. It ended up taking a little longer due to availability of printers, how long the prints took. Some prints were like misprints, so they didn't come out correctly, so you had to reprint them again. So overall, it took about 3 weeks to get it to the final prototype. For trials, we had to redesign a couple times just to make sure the sizes were correct, that everything worked the way it was supposed to work. We did have a couple pieces break as well, as we said before. So just making sure everything was used, the right materials were used. And then the prototype, we had two prototypes. One was just the original cane that just went up and down. But like as mentioned before, there was no wow factor to the cane. So then we settled on our second prototype with the grabbers at the bottom. And then finally, after tweaking a few designs, we were able to manufacture the final assembly.
Okay, facing challenges ahead. So, the three challenges that we really faced over this were the overall wow factor of the project, as Kaylee mentioned before. Our first prototype was basically just a regular cane, and it was brought to our attention that the idea was a little boring and it wasn't really innovative. So, to keep the concept but to add new functional aspects, we added the grabber feature. And then the second part was the sizing of each piece. Excuse me. And so after the cane was printed, we noticed that the shafts were not really fitting properly to each other. So we had to super glue a lot of them together, except for one part. So you still had like the adaptability and you could like still take it off and put it back on. And then there was also manufacturing the parts. And while manufacturing them, some of the materials weren't right, and so we had to like redo that. As I mentioned before, like some of the cane materials didn't work, so we actually had to like redo the shape of the cane so that would work with like the material we chose.
So what we learned along the way, so we learned how to use CAD. We made a lot of different drawings in CAD in SolidWorks. We learned how to use 3D printing. We learned how to do problem solving. And so some thoughts that we had or through our process was what issue are we solving? How can we solve it? And is it possible? And some of the roadblocks we had were how many available printers there were, if our project is functioning well, and how to assemble it. And we also came across time management. So we had limited time and the prints would take a long while and some of them wouldn't be printed well. So that would also take longer.
For our future improvements and work, if this were to be dragged on longer, we'd find a stronger material that can support the cane. Maybe instead of 3D printing the the shaft of the cane, we find like an aluminum pole that would fit properly. Um, Measurements, make sure maybe make each shaft like a little thicker so they fit within each other a little better instead of like slipping out. We had to tape some of them together so they would hold. Adaptability, um, to add to it, be able instead of like the segmented pieces, maybe take our original idea of the shaft raising up and down and combine it into the grabber as well. In our assembly, come up with stronger ideas for connection of shaft, handle, and base rather than just using string, but we ended up changing back to our original wire, which worked a little better because it was a little stronger. Thank you.
You.